Okay, today I'm solving 1600 Codeforces Problem Difficulty level 1600. So continuing in the same row. So T1. So I'm gonna solve next four problems. Okay. So this is the first problem. This is the easy version of the problem. Okay. Marine and Gogu are playing hide and seek with an array. Gogu initially perform the following step. First, Gogu chooses two integer L and R such that L is smaller than R. Then Gogu make an array A of length r r minus L plus R from L to R. Then finally chooses a secret integer x such that A of I will be and set AI to a XOR with a x element. Okay. Marine is then given the value L to R and final array A. She needs to find the secret integer x to win. Can you help her? Note that there are many multiple possible x that Go could have choose. Marine can find any possible x that could be have resulted in the same final array. Okay, and 10 to the power 5 approx. Range of L comma L is always 0. So what is given is that we have an array from 0 to something. Okay, from like 0, 1, 2, 3, 4, 5, 6 to something n, and it is given that L is always 0. Okay, now and we have to find x such that it will gonna result in our given array. So we have also a given array A, and we need to find x such that if we are taking XOR with x, this will gonna result in our A1, A2 and all of this stuff. Okay, so okay, and it is not compulsory that this one is must be like A1 is resulting of one XOR x. It is not compulsory. Okay, otherwise it will be very simple problem. So it is a permutation. So words are jumbled around. Okay. So first of all, okay. So from L to R. So first observation, and I think it is also an important observation that L to R all elements are different, and if you take XOR of same element with different elements. So if you take XOR of X with all elements, the result will also be we all are different. Okay. So if you take X XOR with all the different elements, then all will be the different element. No two will be the same. Okay. So how I'm gonna tell you that why it is so important. Now you're gonna think that it is not so important. Okay. Now if these problem are comes, so first of all the mind come into the bit operations, like if there will be a change in bits, and we have to start from there only, because if they have problem of XOR and all the type of which change on bit on bits type, so we have to focus on our bit. Okay, so because we know that XOR and all the AND operation or operations are change into bit, so we have to consider the bit. Okay, first of all we are saying that we are given like 1 2 sorry 2 3, then 4, something like that, then 5, then 4, not 5. Okay, now if you see that, now what XOR do, if you see for any particular bit, so if the bit is 1 and we are taking XOR with 1, so it will gonna convert into 0. So if, if I'm taking XOR of x of all the elements, so what will gonna happen? So I'm saying that if in the bit representation of x, if 1 is present on this position, if bit is set for this position, then this will become 0. I'm talking about this bit only. Okay. Then in this case it will become 1, it will in this will become 0, it will become 1, and it will become 0. If x is something like 1, if 1 in this position, so all the zeros become 1 and all the ones become 0, so they were gonna reverse out. Okay, all the ones become reverse. So I'm saying that, okay, if I have to find that at this position in x there is 1 or not, I'm gonna take that before that we know that before that we have a array of l plus 1 up to r. So first of all, I'm gonna calculate what is the number of bit at this position. So let's say 3. And if it is same after the in the result also, in the this is our result array. Okay. In the result array, if the number of bit at this position is same, so I'm 100%. Then if oh sorry, if these are different, if let's say it's 3 and now it is 2, then I'm 100% sure that there is a 1. So this bit is set into x. Okay, it will change, that means there is x, there is a 1 in this x. So that's it. So what we're gonna do, if any bit is set, so first of all we gonna count what how many number of bit in L to R, and I'm gonna check same for the result. For the result array, I'm maintaining the same array and gonna see if um like let's say these are the bits, and if number of, let's say before it is 2 0 2 4 and after it is 3 or 0 2 4, then I'm 100% sure that in x this bit is set, because this bit changes if before and after before and after. So I'm 100% sure that this bit is set in x, and and let's say these are zeros, these are not set. Now if we go through from this position, this approach, then we are taking a consideration that, or we are taking uh you can say we are supposing something that the number of bit in this and in this are changing. If one is there, then is changing. Why? Because the number of zeros. So what if the x is set, or if in x this is 1, this bit is present, that means all the number of 1 will be changing to 0 and all the number of zeros will be changing to x, to the 1. So what if, so I'm saying that they will gonna different. Okay, so they will gonna differ. But what if the number of zeros and ones in some array is equal? Something like if we are taking from 0 to 4, so it is 0, then 1, then 2, then 3, so 0 to 3. Okay, you can see that uh, for this bit, the second number bit, number of zeros of, so number of 0 is also 2 and number of 1 is also 2. Okay. And if in some we are taking some x's that this bit is set x is equal to 0 1 0, then result will be something like that. Then this will become, so these are the result. If we are taking XOR with this x, uh, this also become 1 and this is something like that. Okay, so if we are just going with the countings add we suggested before, so number of bit set is 2 and here is also same, but our result suggests that both of the number of count is after and before at this position is same, so there must be no bit percent, but there is. So what I'm saying is that, okay, for some, if there is a, like, this will be present if n will be or r will be 2 keys power I, for 2, 4, and for 8. So for all the elements, for all these things, so 2 power I element, this will be the same, 0 and 1 will be same, the count of 0 and 1. So now this is a kind of a step problems how we gonna go forward. So first of all, before starting this problem, I'm telling you something, the observation, that is, uh, if I'm taking XOR of any element that are different, then the result is also different. Okay, so what I'm taking is, I'm having value from 0 to r. I'm 100% sure that L is 0 in this problem. After that, I'm also taking a, then value will be also become 0 to r, and the value of x. Okay, so value of, like, okay, x can be anything, so values can be anything. Okay, so what I'm saying is that these value are from 0 to 1, and the number of count of zeros and 1 uh, are same. So the count of 0 and 1 are same, such that we are taking of, here the we are taking the example of 4, of n is l is equal to 0, r is equal to 4. In this example, this the count of bit is same. Okay, like 0, 1, 2, and 3. So in this case, the okay, I'm taking something wrong here. Yeah, I'm taking this bit wrong. Okay, my bad. So the count of this bit and this bit are equal. The count of 0 and 1 in this bit and in this bit are same. And if these bit are, I'm saying, are set, then we are not able to differentiate that this we are set according to our observation. What we observe, that the number of count of 0 and 1 will be differ, then we are not able to um, apply that observation in here if the number of zeros and 1 are same. So for this, what I'm saying is that if for any bit the number of zeros and 1 are same, then in x, so x will not gonna depend, it will be 0 or 1. What I'm saying is that if in this case, if the result is also same, okay, so the result is also same, so result must be same, because let's say I'm just taking x is equal to 1 comma 1. So the what is the result? Uh, First of all, let me clear you that now we are solving if for any bit the number of zeros and 1 are same. I'm solving for this problem. We already solved if number of zeros and 1 are different. Then in that problem we can easily know, like, this bit is set in x or not. If the count is different, then I'm 100% sure that that bit is set in x. Now we are stuck at point, if both are, the count of 0 and 1 are same, then I'm saying that you take anything 0 or 1 on that place, it will not differ the answer. For example, if this is here and x, I'm taking 1 comma 1, so after x it will be 1 1 1 0 0 1. This is the result array. I'm taking XOR of these element with x, and it will be 0 0. So number of count of 2 is 1 and 2 is number of count is 2 and 2, and here is also 2 and 2. According our observation what we observed earlier. So I'm just saying that x will be 0 0 in the both the case because the number of bit is not different. So I'm taking that 0 0, or I'm saying that if both the bits are equal, so you can take 0 1 or 1 0, anything you like, or 1 1. So you may take 0 at any place or 1 at any place if the bit are same. So why it is so? Because so if you are checking the bit, this is our result and this is our given array, this is our L and R array. Okay, and if you are taking x, this any of one from these four, the result will be same. So this will be the result. Okay, so the point is why it is happening, why it is so, because I already told you, if you are taking, I'm 100% sure that all the elements from L to R are different. Okay, then if you take XOR of all these elements with X, then it it is also different. It is also different, and it is between 0 to R. Okay, so if you're gonna take 0, put here 0 here in the X, if you put 0 or 1, it will always become okay. If the number of bit are 0 and 1, then it will always be between 0 to R. Okay, so now if you it doesn't matter because the number of bit if are they are same, then the output will be in from 0 to R, and I'm 100% sure that all number in 0 to R in our answer are different, and it is possible that all are taking one number from 0 to R. So it will be a little bit confusion. So what I'm saying is that if you, so first of all what I have to prove is that if I'm taking, if these are 1 and 0, if the number of bits are same in, for x is equal to 2, for the bit position 2. Okay, for bit position 2, the number of bit are same in the result and in the array that is given, in the result that is given, and from L to R we calculated that number of bits are the number of uh, bit are same. So I'm just saying that you can take anything 0 and R. Why it is so? So because if you take 0, then in the result of x, if you take 0 at that position, then also the result will be between 0 to R. It is not going, so it is not going outside the R. Okay, and I am 100% so sure that after the result I am taking 0 at that position, and after the result all number are different, and the number of R will number of so if the length of array is L, so after the I'm taking XOR with X, and after that the length is of course same, and I'm saying that all the numbers are here are different. So here are different and length is same, then I'm 100% sure that all element are between 0 and all number are 0 to R, then I'm 100% sure that they are between, like someone, so that all number from 0 to R is taken in this array also. Okay, this makes sense. So what you may be asked why it is always the result will between 0 and R, why it is so? Okay, so why it is because the bit where this is our given from L to R, the given array, and this is our result, and this is any bit, let's say these are 3 bit and these are 3 bit. So I'm saying that for this bit the number of count is 0. Okay, number of count is 0, number of count is so same, like before it is same 2 and before after it is 2. I'm saying that okay, and let's say 1 and 3, and these are come 3 and 1. So these are two are different, so I'm 100% sure that these two are set in x. This is our x, this is the bits of x. So I'm 100% sure that these are set in x. So I'm taking respective of anything. If both are same, you can take anything. Let's say I'm taking 0. If I'm changing this bit, okay, then it will always become 0 to r, and r, the range of r for 3 bit, it will, let's say it will be 7 or 5. It is 5 if you are taking 0 r to 5 or r to 7, and it will be same if it is 2 ki power I. Okay, I already proved that the number of count of 0 and 1 are same if r is 2 ki power I. That is already proven. Okay, now if these are both are same, I am taking 0 here, then I'm taking 0, then this will become, I'm like, the result of the bit will be, some for some will be 0 and some will be 1, but it will not gonna out, it will always be between 0 to 2 to power I. Okay, so it will always be between 0 to r. Okay, because 2 ki power I will be contain all the, if it is 3 bit, then it will contain 0 to 7, all the number from 0 to 7, that I want to say. And I'm 100% sure that in the result, the if I'm taking this one, if I'm taking 0 at this position or I'm taking 1, so number of, in the result, all the integers are different, and if they are different and all are between 0 to r, then I'm 100% sure that I'm getting all the number from L to R, that is from 0 1 2 to R. I will gonna get all the numbers. Okay, so let's do the code. So this is, the code is very simple, but in this, the hard version of this problem, it is saying that L is not always 0. So for that problem, I'm not 100% sure that it will always be between 0 to R. Then I'm, so maybe, so for some reason, if I'm taking 0 at this position, and it will become 0 for some bit at this position, so it will maybe become lower than L. But here it is said that L is equal to 0. So because, and below that, no number will be gone, because -1 is not possible if from for the bits. Okay, because all number are positive and x is always positive, so -1 is not positive, not possible. So because this L is given from 0 to R, that's why it is possible that we are getting all the numbers from 0 to R. So what we are given? We are given an L comma R, C and L comma R, and for I to N, I'm just taking A of I. Hmm. Okay, sorry, there is no, the length will be, and N will be L R minus L plus 1. Okay, now I'm just taking a vector of count, and bit can be maximum of 17. I'm taking just 18. First of all, for int I is equal to L, and for L to R, I'm then gonna count how many bits are there. If for int j is equal to 0 to 18 j plus plus, if this bit is set in this one, so I'm gonna make, yeah, the count of bit is greater than 0. I'm gonna plus the count of bit. I'm gonna same, I'm doing same, I'm creating another vector count of n, count of 18. Okay, and doing the same thing. Mm, here is ai will become a of I, and it is then in count 1 it will gonna set. Basically we don't need and this one. So if I'm taking x, then it will be good. So now I'm just one, two. Number of bit is 18. If count of I is not equal to count of j, first of all I want to create x. So if they are not equal, then I'm 100% sure that x contains this bit. If they are same or something, then probably it will gonna contain 0 or 1. So I'm just taking 0 instead, or you may take 1 instead. Both will gonna work. Okay. Now see out x. Oh, it's 17. Otherwise, why it is? Okay, x need to be 0. Yeah. Okay, 3. Mm, I need to input x. Okay. Okay. Okay, this is accepted. Or like you are just taking, okay, these are equal. And else if count of I is equal to count 1 of I. Okay. And they are equal, and count of 0 and 1 are also equal. So what will be count of 0 and 1? So count of 0 1 will be, I'm just proving that if you taking 1 instead of like here in this, I'm just saying now you may take 0 and 1 if the number of count of 0 and 1 are same. So the answer will be, so we got the answer anyway. Okay, so let me prove it. So you can code also. So total number of no will be, total number of bits in this position will be n. So because there are n elements, and if it is equal to count of I, then also I'm just putting x. Okay, so if you see that this will gonna be accepted. Okay, so this is accepted. So it will not gonna matter if you put 1 or else it is 1 or 0 at the position if the count of both the bits are same, 0 and 1 are same. Okay. Because the L range is 0, L is equal to 0, so it will not gonna go down further, gonna to go further, further down. This is the second problem. You are given an array, integer array A of size, and initially all the integer of array are equal to 1. You can perform the following operation: choose two integers, then increase the AI using this. After performing all the operations, you will receive CI coin for that, such that AI is equal to PI. Your task is to determine the maximum number of coins that you receive. Okay. So first of all, So range, it is given that range is 10 to the power 3. And first of all, what I'm going to do, so I'm going to make this operation. Okay. Okay. So a of I can be a of I plus a of I by some x, and I know that a of I be between 1 to 10 to the power 3. So first of all, I'm gonna calculate what is the number of operation we'll gonna take to convert it into 2, 3, 4, 5, 6. Okay, using this using this one, using this I'm gonna calculate. I know that for 1 it will gonna take 0, because all the elements are already 1. Okay, initially all the elements are 1. So for 1 it is 0, for 2 it is gonna take 1. So I'm gonna apply this algorithm or this equation for, and I'm gonna calculate how many operations are required to make 4, 5, 6 up to 10 to the power 3. That will be okay. After that, after that, uh, it is kind of a knapsack problem. We are just given a weight, like we are just given bi, so bir, and I already calculate what is the number of operation it will gonna required to make bi b1 b2 b3 b4. And according in, if I'm gonna try in k and I have given that k. So if I'm going to make this b1, okay, let's say it will be converted into, from 1 to bi it will be going to convert it into 3 operations. Okay, now, and let's say k is equal to 5, so I'm gonna make this one, then I will gonna take this ci, that number of coin, let's say it is 5 number of coin. Similarly, it is a kind of a knapsack problem, so we can do it this is a kind of a classic dp. Okay, so what we're gonna do is, we are just given dp of k. We are going to create a dp of size k, and the dp of k at most k operations, so it will not be a, okay. So I'm going to find what is the maximum number of coin I'm going to collect. If I, for this, let's say 2 operation is required, for this 3 operation is required, for to make b3, let's say 4 operation is required, for b4 it is 5 operation is required, something like that. And if I'm doing this, I'm gonna get 5 rupees, 5 coin, then I'm gonna take 6. For this I'm gonna 12, for this I'm gonna take 2. That's, so it is a kind of very classic NTP problem. So first of all, what I'm going to do is, I'm creating a DP. Let's say this is our DP of size, let's say take this example, so then it will be crystal clear for you. Okay, so I'm given b1, b2, b3, b4. Four, um, 4 values are given, so I'm find out that for this 5 operation is required, for this 2 operation is required, for this to make 1 to b3 3 operation is required, to make 1 to b4 4 operation is required. And let's say notes 4, otherwise it will be all are large la, and let's say mm, okay, 4 is kind of good, 4 operation required, and I need, and the value correspond to this, the coin I'm gonna get in corresponding to this, and let's say I'm gonna get, this is c vector, I'm gonna get 8 coins. If I'm able to make this, I'm able to make this, then I'm going 7, similarly 6, then 12. I need to find out how many coins I'm gonna collect if number of operation I can make, let's say 7. Okay, so I just make a dp with index 0, then 1, Okay, make it 0, 1, 2, 3, 4, 5, 6, 7. Okay, so I'm telling that first of all I'm gonna fill out with all minus 1 because I'm not able to make anything else. Okay, and for 0 I'm gonna make out in 0. So if operations are 0, so the result, the coin I'm gonna collect is 0. Okay, now let's iterate over bi, over this array. I'm at this index, so I'm just starting from the behind so that no two operations will be repeated. So I'm starting behind from here. I'm having this value. I'm gonna check if any of these value is is not that it is can be made. Okay, that means that value is not minus 1. Then I'm gonna add this one onto this. So I'm gonna check this is not minus 1, this is not minus 1, this is minus 1. Okay, so if this is minus 1, then dp of, so now I make up to 0 and I have value 5. So I can go up to 5. So if I add 5 more operations into this, the number of operation add, let's say this is I. So this is, let's say this is I, then I plus 5. For that operation, how many coin I'm gonna collect? Let's say dp of I plus 5. So is equal to dp of up to how many coin I'm gonna make up to I, and for this I'm gonna make 8 coins. That's it. So I'm applying this equation, that is dp of I plus 5. So I plus 5, I is equal to 0, then plus 5 is 5, and for 5 I'm gonna make how much? 8 coins. Okay, now I'm going to the second operation. This is 2. So I'm taking how, so what is the number is possible already, like up to this position, like what number is already been, up to that number already is taken. So or okay, so this number I'm starting from behind. So this number up to 5 operation can be made, and if I made 5 operation I can get 8 number of coins. So let's say I'm just, so I'm applying this, so this inequality. So 5 plus 2 is, and number of operation can I made is 2. So 8, 5 plus 2 is 7. So I'm going to 7, and I'm gonna add up to 5 I make 8 coins, and if I also add this one I'm gonna make 7 more coins. Okay, so number of coin is 15. So I'm gonna make 15 coins here. Then after that I'm at this question. Now I'm going after, so this is already can be achieved. Now similarly plus 2 coins at here point, this point, how number coin I'm gonna make 0 plus 7, that is 7. Okay, now I am at index 3. Okay, now I am at index 3, and I'm going to see how number of okay, forget it. So I'm at index 3, so I can make 3 operation in this index if I'm taking this one. So I'm gonna say what can be achieved. So this can be achieved, then plus 3 will be gonna outside the array. I'm not gonna take it. Then I'm gonna see it is, yeah, but plus 3 is gonna 8, that is also outside the array. I'm gonna come out here. Then 2 plus 3 is 5. Okay, so 2 plus 3 is 5. For the 5, what is the maximum value I can get? From here up to 2 I can get 7. because this is 3 na 3 2 plus 3 will be 5. For the 2 I'm going to get 7, and for this 3 I'm gonna get 6 value. So I'm gonna see which one value I'm gonna get maximum. Then 7 plus 3 is 13, so it is higher value, so I'm gonna erase this one and insert it this 13 value. In this case I'm gonna go behind. Okay, I'm gonna go behind and check that, yeah, this is also possible. So plus up to 3, so 0 plus 3 will be 3. Okay, so the this will be value will be 6. It is okay, it will, you will gonna understand it more if I'm gonna make uh, the vertices, like the operation I'm gonna take. Here I'm take 0 and 2, here I take 0 and 3 operation, here I take 2 and 3 operation, here I take 5 and 2 operation. Okay, now you will gonna see it. Okay, now I'm at index last, that is fourth index. Now for 4 I'm just checking, this will gonna make out of bound, this will gonna make out of bound. Now here we go, 3 plus 4 is 7 at this position. Okay, 3 plus 4, 3 plus 4 is equal to 7, and for 3 I'm gonna make up to 6 coin, and for 7 it is 12, so it is 18 coins. So 18 is more than 15, I'm gonna erase this value and put 18 value. Yeah, that's it. Then I'm check for 2, 2 plus 4 is 6, for 6 I'm gonna get 7 plus and 12, that is 19 value, something like that. Okay, okay, let me update the this array also. For the 6 I'm getting 2 and 12, 2 and 4, so 2 operation and 4 operation. For the 7 I'm gonna get 3 and 4 operation, so this will be not gonna give me much answer, maximum answer, so this will gonna give me maximum answer. Similarly, yeah, so now everything is gonna happen. So for 0 plus 4, this one also it will be 0 comma 4, and it will gonna get answer 12. So you can see that now I have to take the maximum from all the array, from this array, from this array I have to take the maximum value I can. So maximum number, these value are the represent the coins, number of coins I'm gonna get. If I make 6 operation, if I make 7 operation, I have 5. So it is given is that I can make at most 7 operation. So I can make 1 operation, 2 operation, or none operation. So I say I have value 7, 6, 12, 19. So maximum value is 19. So my result is 19 while making 6 operations. And which 6 operation? If I'm making 2 and 4 operation, these 2 operations, then I'm getting value 19. That is the maximum value. Okay. So I hope you understand this. This is a classic problem. So let me code this, then you will gonna understand it better. And if you understand this, so you can code by yourself. Pause the video and code by yourself. I'm gonna get given T, B and C. Sorry, int and comma again. Vector of C of size n and B of size of n. For I to n, I'm gonna take C, B of I. Then for I to n, I'm gonna take C of I. First of all, I need to take how many operations. So I'm just making a operation of size. It I'm already known that the maximum size will be 1 e to the power 3 plus 10. Let me operate operations. So for int I is equal to 1 to I less than equal to maximum I plus plus. For int j is equal to 1 to j is less than equal to I and j plus plus. I'm applying the same operation that is given, that op of, so int z is equal to I plus I by z. So d of z, operation of z is equal to max or minimum of, I need to my minimum operation required to make z or operation of I plus 1. Okay, and if z is greater than or equal to maximum, I'm gonna continue, so it will not give me any error. First of all, let me run this operation here. Okay, now just add dp of size, let's say size of size k and all are -1, and I know dp of 0 is equal to 0, and also here all are maximum, let's say 1 e to power 9, and dp of 1 is equal to, because 1 is already present, so d. Okay, now I need to apply the operations. So now I is equal to 0, I less than I plus plus. Now for int j is equal to k and j must be greater than equal to 0, j minus minus. If first of all I need to make j plus d of b of I. To make b of I, how many operations are required? Oh man, this is operation. How many operations required? And if it is greater than k, I make continue. So best idea is I'm just starting from here. Okay, let's say it require that much operation, 5 operations, so I'm starting less than 5. So k is 7, then I'm starting 2, because if I'm starting from 3 4, anything that is greater than, it will gonna give me exceed the k value. Okay, so if dp of I j is not equal to -1, then it is can be taken already, it can be achieved already. Then dp of j is equal to, so I need to take then next can be j plus operation of this one. Now dp of next, first of all, if it is already -1, then number of operations will be dp of I plus c of I. Number of up to I, how am I going to make, and for this particular gonna, what is the number of coins. Else if it is not -1, then dp of I'm checking for the maximum coins. So how many coin I make up to this point, and or this one, the maximum one. And then in maximum coin, I'm gonna make out maximum coin for int I is equal to 1 to I less than equal to k I plus plus, and maximum coin is equal to maximum coin comma dp of I, then see out the maximum coin. Okay, yeah. Where it is 602 is giving me wrong, where I make something wrong or something. Okay, I is going to that is okay. For I to n and k is all are -1, dp of 0 is equal to 0. For I is equal to less than dp of I, j will be -1. If it is -1, I'm gonna, if it is not -1, I'm gonna make the next will be j plus I, then dp of next is equal to, if it is already, so how much, okay, so that is j. Yeah, 930, yeah. Why it is giving me wrong answer? Maybe it, answer maybe exceed or something like that. No, it is giving me differ expected 14 found 0. I don't think so. Okay, let me check once. Okay, let me check the ranges maybe. So range of b of I is 10 to the power 3. So I'm just making 10 to the power 3, that is okay. And I can be maximum to maximum, that is okay. Okay, p of z is equal to of p of I plus 1. Okay, yeah, that's fine. I think this is also fine. I'm making a k plus 1 and the value of k can be 10 to the power 6. 6 into, how many operations I'm gonna make it? If dp of next is -1, I'm gonna make it dp of next is equal to dp of j plus c of I, number of points I'm gonna collect here, and it will be this one. And from I is equal to 1 to k, or let's say if it is it is okay, it is already 0. From 1 to k, I'm gonna take out the maximum coins. I think so that should work fine. So where is the problem? In the 18th number, expected 14, found 0. Give me a sec. And comma k dp of next is equal to -1. Dp of next is equal to dp of j plus count of I, and dp of next is equal to max of dp of next plus what up to j, and plus what is the operations I'm gonna make it. I think so it must be 100% true. Expected 14, give us 0. Maybe the number of points operations I required for one is 0, and sequence I'm gonna make a number of operations I'm gonna make. Okay, this is also good, that is Okay, let me write 4 to power 13. I still don't know why it is so many. B of n, C of n, I'm taking all the values up to n, these uh, C1 to n, then n elements. That is totally fine. I'm just making up to k operations for the 0 one. I'm gonna make it is not possible for y to n. K will be minus what how many operations I'm gonna make, and it will be less than equal to 0 to. If it is 0, then I'm making that number of operation. If it is minus 1, then I'm making that much of coin. And if it is so, dp of next is equal to dp of next comma dp of z plus I. And the max is always I don't think so there is any problem. It is 100% correct. Why it is some problem? I didn't get it. Expected 14. Let me see once a tutorial. Mm, this is the D problem. Okay, that is same. Uh, and I'm making an X. Sum will be the so so it is taking the D of I, then it is applying the same algorithm. dp of b of I is equal to dp of j plus c of I, and it is returning the max element. It is 100% correct. Okay, let me see. It is I'm taking max element. Oh, let me give a second. I'm gonna figure it. Okay, I got it. So what is going on here? So actually we are taking from 1, but we need to take from 0. Why it is so? Because I know that for making 1 we need 0 operation. Okay. So for that maybe B for B of for making 1, the coin will be maybe some coin will be there. Okay. So code will be same, some everything is same. So just we need to start from 0 only. That's it. Yeah. Okay. So this is the third problem. So Igor in his 11th grade, tomorrow he will have to write an informatics test by street teacher in the school. Okay, you don't know How the test will be conducted? First of all, the teacher will be give each student two positive integer a and b. After that, the student can apply any number of following operations any number of times. Okay, there are three number of operations. I need to make a is equal to b, and a is always less than b. So what I'm given is that, okay, okay. So we are given a and b. We are given a and b, and I have to somehow make a is equal to b. So first of all, it is given that 10 b is less than 10 to the power 6 for all test cases. So I'm gonna get run. So I can number of operations can do. I can increase a or and increase b, and I can increase a up to b because I have to make a is equal to b. So first of all, I'm gonna check for all a. So I'm just making a1. A1 is from a to b less than equal to b. So I'm gonna increase because it is in 10 to the power 6. I'm easily gonna make it in O of n. So this is a kind of beautiful question. For I'm just also checking for all a1, that is a plus 1, a plus 2, a plus 3 until b, and what will be the minimum answer. So now two operation is remaining. I have to increase b, or I have to take the or operation, that is a or b. Okay, now you can see that by making or operation. Okay, now for any constant a, I need to first of all, which is what or operation do. Or operation, what, let's say if this is our a and this is our b. So if we take a, if we make a equal to a or b, then a will gonna make all the, for all the bits of b that is not present in a will be also present in b, also present in a. So it will something look like this: 1 1 1 1. Okay, okay. So if what we want to do, I'm already known that b, a is always less than b. If I'm gonna make a, so a or b, then after that, I'm 100% sure that a will be greater than or equal to b. If it is greater than or equal to b, then I'm gonna increase b plus plus. So what I need to do is I need to make a or b operations. After that, I will gonna complete all the that is all. I will gonna make b equal to a, that is this a, by increasing b. Okay. So for the minimum number of elements, I'm gonna make a should be smallest. A should be just greater than equal to b. Okay. How can I make a just greater than b? So first of all, let me if a is something like this is a, and we have this is b. So this is a, this is b. I'm gonna take this is c. C can be anything. What I'm saying is that I need c. I will make b to c, and I will make a is equal to a or c, such that a will be just small greater than b. So first of all, I'm saying that okay, this is not in a, I'm gonna make it in a. This also same. It will be if in the bit representation, this will be 0th bit, that is 2 to the power 0, that is 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, something like that. Okay. After that, if so, I need this in the c, this in the c, so that after the or operation, these bit also be present in c. Now after this, 1 is present in c. 1 is present in A. Okay, now after this point I'm 100% sure that A is greater than B. Okay, now I'm gonna stop my C here. Okay. So this is my A, this is my C. If I'm taking the XOR of both, OR of both, then A will become A XOR C. That will be 1 0 1 0 0 0, and our C is 0 0 0 1 1 1. Then it will be, then A will become 1 0 1 0 1 1 1 1. Okay, so I'm saying that this is just greater than B. Okay, so I make three operations. First of all, from there is a B, from B I need to make C, and then I need to make operation, that is I make to OR operation. Then after that, from C I need to make it A. So after this operation, then A will become A XOR C, and I need to make it A. That's it. Hope it will be clear. So you may say that why I'm taking this, like this one. Okay, first of all, you understand that these will be required. Why? Because to make A greater than B. Okay, because we can do only one operation, that will we gonna increase B. We can't decrease B. Okay, so these are okay. You are, so why it is so? Because if I'm not taking this one, if I'm not taking this one, then C is greater than, smaller than B. B is still greater than, but I need I need something, so that because I can do only one operation, that is plus plus. So B, C should be greater than B. So it is possible only if I make something, uh, something one, I make bit, I will set bit that after these two bits. Okay, because these two bit is required in my, to make A greater than B. These bits are required. I'm gonna make one bit just after these bits, so that it will be greater than C also, it will greater than B. And why it is so, I'm just taking this bit because this bit is already set in A also. Okay, so if this bit is set in A, then A XOR C will, so these two will be make change in this OR operation, so it will become something messy. Okay, so what I need is some, this is my bit representation. You can say something like this, and I have this one. So first of all, in the C, this is C, these two bits are required, and after C I'm just taking the one bit that is set in this one in the A, so that A or C will not gonna, so this bit will not gonna affect. And why I'm taking this bit? So because I need to make C greater than B, because first of all I need to make B equal to C. So number of operation will be, so I'm only increase the B, so C must be greater than B. So I'm just, if I'm taking this one, and so this will be, so if I'm taking this and all are 0, then I'm 100% sure that C is greater than B, and it is also not affecting A because it is already present in A. So now we have two operations, then we are just taking two in one of these two bit, so that it will be greater than B and not affecting A also. So why we take this one? Because if you take at the end of the, okay, if you take this bit instead of this one, so if you take this bit instead of this, so answer will be not will gonna affect. Why it is so? Because at the end, if I'm taking A XOR C, it will be is equal to 1 0 1 1 1 1. Okay, and if I'm taking C is equal to 0 0 0 1, all are zeros, 0 1 1. Okay, I'm taking C, this one. First of all, from B I need to increase B plus plus 1 up to C, and then from C I need to increase up to the here. So it will be, so at end I need from C how many operation I required, how many plus plus I required, that is this one 0, this one and this one. Okay, I need these operations. And if I take second case, what I am taking, I am taking this one, that is this bit instead of this. So in this case you can see that the number of bit will be this one. So this is this one, this one. Okay, let me make it clear a little bit. So it is 0, then C will be, it is 0 0 0 0 0 1 1 1. So to make this is C and this is A or C, so to make both is equal, so I also need to add these bits into this C to make them equal. So you can see, if first of all if I make this bit from B to C, I need to increase this in here, in this position. Then in other position, from C to make A is equal, then I need to make all other bits that is present in A equal. Okay, if I take another bit, then the answer will be same. So, because at the end of the equation, I mean in my C, I need all these bit to be present, so it will not make any changes in the answer. Okay, because in my C I need all bit to be present, that is in the A. Okay, so let me do the code for the same, for this problem. So this is a little bit easy problem. So we are just given A and B. A. Okay. Okay. Now for int I is equal to A1. Okay, sorry. A1 should be is equal to A, and it should be equal to less than B, and A1 plus plus. So in answer, how many answer I require? I need to B minus A. First of all, I'm making set answer to this value. Now 10 to the power 6, so value can be, what is log to 10 to the power 6, and 10 to the power 6. So it is will be 19.9920 we're gonna take. Okay, so from 20 to I should greater than equal to 0, I minus minus. I need to make a C point. So if this bit is present in I, okay, this is bit is present in I need to store in C also. And if it is not present in I, and if it is present in A, that is A1 now. If it is present in A1, so what I'm gonna do is, I'm gonna include this bit in my C, and I'm gonna take it a break. Okay, that I tell you in the whiteboard, on the whiteboard. Okay, now what will be the temp answer here? So first of all, number, okay, so let me tell you what is the answer. So answer will be, first of all, from A I need to make A1, so that will be A1 minus uh, that is A1 minus A, and from B I need to make C, and from C I need to make A comma A1 or C. Okay, so it will be plus. Now I make C, that is C minus B. After that, if up till this point, okay, now I am reached to point C, For some variable maybe c, I this is already equal to a, okay, a1, okay, I maybe achieved, maybe both are equal. If it is not equal, if a1 is not equal to c, then I need to increase c to, I need to take a XOR c, and I make increment plus one operation to take the XOR. That's it. So answer will be, first of all, a1 minus a, then plus b, c1 c minus b, and if c is not equal to a, then temp answer will be c XOR a minus c plus 1. That's it. So answer will be minimum of answer comma temp answer. Okay, this seems good. Oh, it is giving me wrong answer. 42 expect 3 found 4. Hmm. Okay, so this is a1. Okay, because I need to make a1. Okay, not a, my bad. Okay, I think it is accepted. Yeah, it is. This is the fourth problem. So there are any heap of stones. The ith heap as hi stones. You want to change the number of stones in the heap by performing the following operation once. So you go through the heap from third heap to the nth heap in this order. Let I be the current heap. So okay, I need to increase the ith one by d and I2 one by 2d. Okay. So what is given that? We are given some heaps. So here h height the h1, there height h2, there is h3, here is h4, here is h5. Okay, I need to do something such that uh, I need from third to n. I need to make operation in a, so you can see that there is a, I need to make this operation. Okay, and in this operation so that I am starting from 3, then 4, then 5 in the same process. I have to make the operation in the same process. So first of all, I'm taking this something here, and let's say of a multiple of d, of multiple of 3, then 3 by let's say I'm taking x, that is 6. So I'm making 2 third here, 1 third here, and 2 third here, that is 4 here. Similarly, I'm taking here from 1 third here and then 2 third here, similarly operation. Okay, so this can be done by the using the binary search. So for any binary search, I make like what is the minimum value I can get, and for that minimum value I'm gonna set if it is possible or not. This is simple problem. Okay, so you can see that any of these value is not consistent, but if this is the last value, then I'm 100% sure that this is should be at least greater than this one. This is the, like for the binary search, then I'm searching for any x value, so it should be, I'm making this x, and all the values I'm just making um, giving them this is d and all the remaining value to d, something like that. I'm doing this operation. Okay, so let's hop into the code. And okay, so wait a minute, something on my gate. So hi, so let's do the code for the same. So okay, I'm just starting from behind, because I'm 100% sure that there is no change gonna have here. Okay, but there, if I'm taking something from here back to back, then I'm not sure that how many thing will be, how many value will be gonna come if here, because this will is kind of a dynamic, this value is changing but this value is not changing. So that's it. Okay, What is given is that we have n int n scene n and a vector of int height. Height will be size of n, and for I of n, I'm just taking h of I. Okay. Now int l is equal to 0 and height can be is equal to 10 to the power 9. Let's say 10. And I'm checking for r greater than equal to n. And if it is possible for the mid, that is h array, int mid is equal to r minus l by 2 plus l. If you know taking, like if you're taking l plus r by 2, then it will be sometimes it will gonna exceed the int value, because if l and r 10 to the power 9, so it will be 2 10 to the power 9, so it will be gonna be increased this value, so it will gonna give you out of bound. Okay, maybe it will not maybe gonna give, I didn't check this one, but for some cases it will gonna give for some problem or some cases. Okay, if it is possible, then I will make l is equal to mid plus 1, else r is equal to mid minus 1. I'm just putting the answer, that is r. So bool, that is okay, int mid and then vector of type h. Okay, for int I is equal to, I'm taking n minus 1, I is equal to 2 and I minus mine. So n is equal to h dot size. So what I'm taking is, uh, first of all, if a of I is smaller than mid, then I'm just written that is not possible. Else, oh sorry, this is h. Else I'm just taking the extra value. How many extra is? That is h of I minus mid, and I will gonna pass it out. So extra will be is equal to, I'm making it a power of 3, and a of I minus 1 will gonna add extra, and a of, sorry, and this is h, and h of minus 2 will be gonna need extra into 2. That's it. And at of last I need to check the uh, h of 0 comma h of 1, because all value are checked but 0 and 1 is not checked. It is less than mid, I'm gonna return it false, else return it okay. So okay, let me make another variable that is fixed of size n, and f is equal to h. So what is gain saying is that we have to make operation from here to here. Okay, in this direction from 0 to n, but I'm making all the operation from last to first operation in the reverse order. But you can see that how much value, because at any point how much value and can I go, can I shift, can I, how much value can I shift, that is the maximum value that is already present at this point. I'm gonna not gonna shift, because when I'm starting shift this position, this will be the original value that it have. Okay, so extra will be, so it should not be how much value can I shift, it is should be fixed f of I. Okay, here we go. 15 1 2 3. Oh, and it is not giving me correct. Okay, let me check it out. For n height is h, L is equal to 0, R is equal to this one. Okay, make it answer. This is also not. I am checking for this mid, and this is I have H, I n minus 1. Okay, this is. Okay, here we go. It is giving the correct answer. Okay, it is accepted. Okay, thank you.